Welcome to today's session, Apex Nuances, Transitioning to Force.com Development. My name is Jeff Karp. I work for Great American Insurance Group on the annuity side of the house in Cincinnati, Ohio. And I've been working with Salesforce for a little over 2 years now. This session is tailored for people who are coming to Apex from other programming languages or just starting out in general. A lot of us didn't begin there, and so this focuses on some key principles to pay attention to as you get in there. Safe harbor, everyone's seen this by this point. We won't go into too much detail on that. And here's today's agenda. All of these topics we could really break out and have a session of its own for each one. So we're going to be hammering at a high level on most of them and then digging in a little bit on a deeper level on a few of them and hopefully even giving you a trigger design pattern to take home with you as well. We'll share. So we'll first cover governor limits, execution context, DML versus database class, triggers as we mentioned earlier, bulkification, asynchronous Apex, and unit testing. So just to see who we have in the room here, not all of us, like I said, started in Apex. Who came from Java? I figured that'd be pretty heavy. How about .NET languages? Nice, that's where I came from. Ruby, anyone? Mobile or web frameworks, Angular? Great. COBOL, Basic, C, C++. What about anyone Apex born? Has Apex been their first language? One? Nice. Good deal. Good makeup. So the first thing when you get into Apex that's different that we're looking at is governor limits. And some developers cringe when they hear this because we feel like our hands are being tied, but really I like it because it enforces you to code efficiently up front. And that helps in the end where you're not throwing something out into the production environment and then, hey, I need to performance tune this. You find out a little later. And the main reason for that as well is that Salesforce is built in a multi-tenant architecture, and they don't want you to monopolize those resources that the other customers are using with some never-ending for loops and whatnot. So they're there for a reason, and in my opinion, they're a good thing. Some of the most common limits that you'll see are the DML statements when you're making those calls to the database, SOQL Queries, which is the Salesforce object query language, and queries issued, and then records retrieved, which is your total result set. So if you have a query that you run in Apex, which kind of goes over 50,000 or whatever your additions limit is, then you'll get that. So those are the three most common ones that I see that you have to kind of pay attention to out of the gate when you get in there and start coding, and we'll get into more of those a little later. Something also to note is that limits are constantly increasing. So with each release that Salesforce does 3 times a year, you'll see a lot of these limits increasing and sometimes even being removed completely. So it's something to pay attention to, but at the same time, they might be gone at some point. So when we talk about limits and getting in there and tools to help you, one thing is the limits class in Apex that Salesforce provides, and it gives you access to governor limit specific information. And what that means is you'll see 2 methods for each limit. And those methods, as we see below in this code example, one is get DML statements, and the other one is get limit DML statements. And so what these 2 methods will provide is it'll tell you how many have we used and how many do we have to use, how many are available for our addition that we're working with here. And so we have just a simple snippet of code here that just goes through this example. You'll see that we're just newing up a new contact. We insert it using the DML insert method there on line 2. And then in lines 4 and 5, you'll see that we're just doing a debug statement just to kind of be an example on that limits. And in the debug log below, you can actually see that in the first entry there, it tells us that we've issued 1 DML statement. And in the second line, you'll see that we have 150 to use. And so as you get into some more complex code and whatnot, you can utilize this class to kind of see where you're at or provide even some monitoring or within your unit tests as well. So when we talk about limits, you have to wonder, well, when do they start and when do they end? And when we think about that, we come to the execution context within Apex and Salesforce. And it's really kind of your transaction scope It's the lifetime of a transaction, and it serves as the boundary for governor limits. So when you think of an execution context, you can think of a user clicking on a button, executing an anonymous Apex block of code. That'll be the start. And then when that code finishes and runs it through its transaction, that will be the end. And so that's the kind of the window in which you have to work with when dealing with your governor limits. So that'll be the start and the end, and anything that you do in between counts towards those governor limits. Some other pieces about execution contexts that you might want to look into as you're getting in and coding is the use of Savepoints. So execution context talks about the life of the transaction. Savepoints offers you some transactional control options within there, because if you get an error and you don't implement Savepoints or anything else, it'll roll back the entire transaction. And so with Savepoints, you have the opportunity to kind of go in there and set up some custom control options based on what your code is doing. So these are good for exceptions, and another great point that my Salesforce developer evangelist made is business logic. You can use those for that as well, where you might run into a certain condition in your code where you want to go ahead and roll back some of what you've committed to the database. You can roll back DML, emails, and even calls to add future methods. Excuse me. So here we have a basic example. In line 1, you just see us newing up an account and inserting it. And then it's basically doing an assert. It's selecting using SOQL that account and specifically the account number, and it's just validating that it's null, if you see there in the first parameter of that call. Then it sets a save point in line 6. In line 9, we'll go in and we'll take that account, the A variable, and we'll set that account number just to 123. We'll update it. We'll assert that it was updated. Line 15, you'll see that we'll do a rollback, so it'll get us back to that save point that we set, and then it'll just assert that it is null again, where that 123 value is no longer there. So that's just a simple example of how to use save points within your transaction. So after talking about execution context, we have DML and database class. So you might wonder, when do I use one as opposed to the other when I want to insert or manipulate some data? And our DML operations in Apex are insert, update, upsert, delete, undelete, and merge. And really, in my experience, I've always used the DML. I haven't had a scenario to use the database class yet, but it's very straightforward, very easy to use. As we see here in this code example down below, what we're doing is we're setting up a list of accounts. We're newing up 2 different accounts to that list, and then we're inserting it. And we'll actually get into a little more detail on what that means instead of inserting a single record a little later in today's session. Database class is your other option. So when would I use the database class as opposed to the DML options? And the scenarios in which this would come to play is when you want to maybe use partial record processing. Let's say you're inserting 100 records at once. And if 4 records fail, you say, you know what, I want to go ahead and stay with the 96 that went through successfully. The database class offers you that flexibility. As you see on line 7, there'll be a Boolean flag in the database.insert method, and that will allow you to toggle if you wanted to do partial record processing. The database class also offers you the save points, as we saw earlier in the slides. It also has the convert lead method. So if you're ever doing any code where you want to convert a lead to a contact, account, or an opportunity on your own, you can access that method from within the database class. And most importantly, to use the database class is it returns you a result object array. So if you needed detailed results on every single record that you put in and what happened, this would be a great option for you. As we see below in the code, same code as the last slide, where we're newing up that account list in the first 4 lines. Line 7, you see that we're getting back a database.saveResult array. So that's the array of results that we're getting when we call that database.insert method. And so if you needed to do a little extra with it, as you see, we're looping through the array down below in lines 10, and then we're even logging out something in the system debug log. So that's an example where if you just did insert and your list, would insert in, but if you actually wanted to write out a log or do some other logic, that you'd be looking at the database class as an option for you. So triggers are a very important piece in Apex. It's something that's kind of unique. If you've worked with databases and some other languages before, you might have had some experience with similar pieces like the Apex triggers. But one thing when we look at triggers is, we get very excited when, our business or stakeholders come to us and they ask us to code some, I can do that easily in a trigger. But the key is to use declarative first. And when I say declarative, I'm talking about workflow or process builder. And using those options to empower your admins so that they can control as much as possible. But in the event that they cannot satisfy their business requirements using those two, then triggers really come into play. Just some best practices before we dive into some code and a sample model here for triggers is try to use one trigger per object. I've seen before where you have multiple different triggers for the same object. So let's say you have a contact object and you have 4 or 5 different pieces of functionality you want to apply in a certain event. Don't create a trigger for each one of those events. Create one and then kind of use utility classes to have all that logic that it calls. Another thing is you want to keep them logicless. And what logicless means is don't have any code in the actual trigger. You want to call out to those utility classes in that, and we'll get to that in a minute as well. Bulkify is a section ahead of us. You can't talk about all these without kind of stepping on each other's toes as we go along. So we'll dive into bulkifying and bulkification in a little bit here. Another important piece is to defend against recursion with static variables. With the execution context, there's static variables live just for the scope of your transaction. So what you can do is you can use static variables to prevent from entering a trigger, then going somewhere else and coming back into the same trigger. And where you might see that occur is you may create a trigger one day, let's say on the update contact. Whenever someone updates a contact, I want to fire this trigger. And then you might have an admin that comes by, 3-4 weeks later, and they throw a workflow rule in there that says, hey, when a contact gets updated, I want to update this field on the same contact. And what that could possibly do is your trigger could run, could update the contact, cause their workflow rule to run, and then come back around to your trigger again. And so what we want to prevent is it from coming around the second time. And we'll show an example of using static variables here in a second on how to do that. And then also note to utilize the trigger handler model, and that's what I'm hoping to give you guys today to take home that I'll post after the session. So here we talked about the static variable and preventing recursion. We have a simple trigger example here. Trigger's just on a task system object, so we've named it task trigger. And you'll see that it just runs after insert, before update. And the first thing we do there on line 3 is we declare a static Boolean variable called first run, and we say true is what we set it to there. You can ignore the trigger handler below that for now. We'll get into that in a second. And then we go into a try catch here, and on line 7 we do is if first run. So we're checking if this is the first time that we've passed through this trigger. And if it is, we'll enter that code block and we'll set first run to false, and then we'll run our trigger logic for that task. And so here you'll see that it'll prevent us where if we do hit a workflow rule later that sends us back in, it's going to check first run because we're going to be in that same transaction or execution context, so our first run true value will, or a false value will persist, and then it will not enter that block again. And so what I'm going to do now is just jump out here and show you a model for triggers too that might help, that helped me when we started off developing in Salesforce. There we go. And we'll talk a little bit about why that's important. I'm going to have to go over here to... That didn't work. Bear with me. It's just a screen sharing. I got to find the mouse. There it is. Okay. So here's the trigger we just looked at. And we said to ignore the task trigger handler then, but now we're going to start looking at it. So we have this task trigger handler, and we knew it up there. And then in the try catch on line 9, you'll see we call handler.execute. And so with this model, what we're doing, hang on, let me just get the mouse again. So we're going to go to a base class that we've created. And so this is an abstract class, and what we're going to do is create a trigger handler for every object that we have a trigger for. So as we saw a second ago, we were calling the task trigger handler, and we'll get to that next. But what this does is it creates a model in which your triggers are going to execute in the order. And so here on line 4, you'll see if trigger.isBefore. So you can take your before, your after, your update, your delete, all your kind of trigger event options, and you can organize them in the order that you want them to run. And then you can kind of, inherit from that to enforce that up the ladder for all of your triggers to run in the same order and do that. Because another issue with having multiple triggers is you don't know which one's going to run first if they run concurrently. And this kind of will structure them in a way where you can schedule out which one's going to happen first and last. And so here is just the base class for the trigger handler. And then if we pop in, we'll see an example. Let me just move that out of the way. Of the task trigger handler. So this was the one that we were executing within that trigger. Here you can see, since we're extending that trigger handler class on the end of line 1, that just means we're inheriting from it. And then on line 3, we're overriding the before insert. So hey, if you have a task trigger that you want to do something on the before insert event, then you'd add your logic there. Same thing with after insert after that. So this is a good model to kind of get you structured in how the code executes, and then keep consistency amongst all your triggers. Like we said, make them logicless as we let me pop back over to the trigger. You see here this is logicless because really it's just calling handler.execute. All your logic happens in that trigger handler. And then if it got extremely complex, you can even call out to utility classes from your trigger handler as well if you wanted to. And then your base class is structuring how those execute. All right. So like I said, though, you could do an entire session on triggers. We're just kind of touching on the best practices and trying to give you guys a model as well if you're just getting started in Apex to use when you go home today. So we mentioned bulkifying and bulkification earlier. This is pretty important, too, to avoid those governor limits and stay efficient. Here you'll see 2 examples, and this deals with bulkification of a trigger. When a trigger executes, it can handle up to 200 records at a time, depending on what's going on. Let's say you're using the data loader or sending in a batch of some sort. You might be sending in 1 to thousands to millions of records. And so it'll fire for 200 records each batch. And here are 2 examples. The first one is not one you want to follow. We'll look here, and this trigger here is on the account object. And on line 6, you'll see account equals trigger.new, and it's getting the first record in that collection. The trigger.new is a context variable. Whenever you're in a trigger, you have a number of context variables that are available to you. Trigger.new is passing in all of the records coming in that batch for that trigger. And so here you can see that we're only handling one of those, and that's not what we want to do. What we want to do is we want to handle all the available records that are coming into that through that batch into that trigger. And so if you look below on the bulkified trigger, what we'll have is you'll see a for each loop that's for eaching through that trigger.new on line 6. And so that's going to go through and process each record or do something. In this case, it's just kind of adding a name in there to the description. But you'll handle all of them, and you'll touch all of them, because the first one will actually only work the one record. And then if you had 199 other records coming in, it would do nothing with them. So you want to go through and handle everything that comes in that trigger.new map. So we talked about bulkification. We also have to look at DML, which is something that you'll most certainly see in Apex. So non-bulkified DML, here we'll see a for each loop. And in that, we see a delete contact call. And so what that's doing is for each contact in that list, it's running an individual DML statement, and that's not what we want to do. In the bulkified DML section below, we'll see that we create a list in line 20 of contacts, and then we for each do some contacts on 22, and then on 24, we're adding to that list that we have the contact because it met some criteria and we want to actually do something to it. And then line 27, we're just checking to make sure that list isn't empty, because if it isn't, we want to do something. And then we're deleting that entire list. So in those first few slides with the account, we were kind of adding several accounts to a list and then conducting an action. Here you can see that we're performing the action on the collection and not an individual record. Something also to keep in mind that you'll see is, okay, yeah, great, we have a contact list, and we're doing an operation on that entire list. But if you're in a trigger or if you're in somewhere else in code and you have multiple different objects, S objects, in multiple different collections, you can also create a generic S object list, put all those into the same collection, and then run one DML statement for all those different types as well. So now that we've gone through bulkification, asynchronous, another important piece, where we have 4 different options in Apex. And these options are good because, one, they're asynchronous. B, you can get a boost in your limits when you use them. And so a lot of times you'll use them to do some longer operations or some different things that you wouldn't normally be able to do. So one option is future methods. It's your most basic. For long-running methods, avoiding delinked transactions, callouts. Here you'll see in the code example below, line 1, it's very simple. To turn a method into a future method, all you have to do is add that annotation on top. You'll even see the attribute there for a callout. You have that as available as well. But that's the most basic one. Then you got to think, okay, well, when do I use let's say, queuable Apex, which is another choice. And queuable Apex differs from future methods in a couple ways. One, you'll actually get a job ID. So let's say you're going to make a long call, but you want to kind of monitor that call. And queuable Apex will give you the option of getting an ID back for that job. There's an async Apex job object, system object, where you can actually get a record for your queuable code that you've queued up to execute. And so that's one way. Is, let's say if you wanted to monitor a job by its ID. You can also chain jobs together, which is another big reason to use queuable Apex, where you can kind of daisy chain them together. Once this one runs, run that, or at the end of this queuable job, check again and see if there's any more records that I need to process. There's actually a couple sessions. I went to one yesterday just about queuable Apex. So as we said, we're just touching on these asynchronous functions at a high level. You could have a session on future methods, queuable, and even batch and scheduled. But batch Apex, we've used this in our org a few times for some maintenance jobs and for setting up data for the morning processes that we have that run. And these are good for when you want to iterate over a large amount of data volume. Let's say you have millions of records and you want to kind of run through a process every morning. Batch Apex is what you're looking for to do that. It also, depending on your edition, for us we have Enterprise, and your query limits for SOQL is 50,000. When you run a batch job, you can actually get much more results. So if you're finding where you can't tailor your where clause in some queries to process data, you might have to start looking at batch Apex to extend those limits to get through them. Scheduled Apex is another option you have available, which actually works very well with batch Apex, where you can write a class where you kind of wrap a scheduled class around a batch Apex class. And then the reason that's good is because it empowers your admins. If you go into Salesforce in the setup screen, there'll be a scheduled jobs section, and they can actually schedule batch Apex at that point because you've wrapped it in a way where they can execute it as well. So it offers where you can execute the code at a certain schedule within Apex, or you can just create a wrapper to expose those batch classes to your admins when they want to set up certain maintenance jobs or run different processes. So unit testing, not too different from other languages if you've been around and doing it. One thing that is different is there's a hard stop, 75% code coverage requirement. So if you don't hit 75% code coverage and at least 1% on your triggers, you're not going to be able to deploy. And so you'll see some different things now within Apex when you take in that requirement. You know, I say assert expected behavior here, and why I say that is you'll see a lot of people that'll write unit tests to meet that requirement, but they don't necessarily assert anything at the end of the test. It's more of a coverage con to allow them to deploy. So one thing to keep in mind is make sure that your unit tests are asserting expected behavior at the bottom of them, and they're not just kind of exercising the code running through where the only time they would ever fail is if it was some sort of unhandled exception and whatnot. Another piece that's nice about Apex is there's no data cleanup. If you've used tests before, a lot of times you have to add data and then clean it up at the end so you don't muck up your database unless you have a separate test or you do it in memory. So that's nice. When you're creating your unit tests, these are the 5 ones you really want to think about for every method and piece of logic that you have. One, you want to do single action. You know, make sure a single insert or something of that nature works. Then bulk action. Try to insert or, you know, do the action over 250 records. Because what that will do is it'll exercise that 200 in your triggers if you're doing those, and it'll make sure that you're not hitting any limits and that your code is bulkified. You want to have positive and negative behavior tests. You know, test for happy path, test for unhappy path. And then one that's caught us quite a bit is the restricted user. You know, they have a run as method in Apex where you can set up a restricted user, and in your unit test you can have the execution context execute as that user. So maybe they don't have rights to certain fields or other operations. You want to have those restricted user tests as well to catch those instances. So some more nuances in the unit testing in Apex. One is the test. There's a test class in Apex, and it has 2 methods that are important on that. One is start test and one is stop test. In this code example below, you'll see that we've got a test method, demo test, and we go in there, we new up a new contact, and we insert one contact record. Then you'll see that we call test.startTest, and then we'll have a contact result that we get back from a method called processContact, and then we do test.stopTest. Well, what does that mean? So what these methods are good for is it kind of sandboxes you a governor limit set for anything that you run in between it. And so what we've done is we've sandboxed processContact method from where we set up all the test data above. So in lines 33 and 34, we set up some test data, and you might set up hundreds of records in a unit test. But you might not want to count all those inserts and all those operations against what you're actually going to test in your unit test. And so that's what this is doing. It's giving us a clean slate of governor limits for that processContact method. Another piece that it handles is that stop test method will make sure all of your asynchronous code executes before it moves on. So if you have any asynchronous queuable futures and whatnot, that will make sure that it all ends. And so your governor limits, you know, will be fully exercised for that execution context. And so it's good because it'll sandbox it, and it'll make sure that all of your asynchronous, you know, maybe processContact calls some asynchronous methods, and it'll make sure all of those finish up. And then below we see where you just want to assert your results down there. Another piece to note is the test visible annotation in Apex is something I like. You might have a private method in one of your classes, and let's say maybe you can unit test that method, you know, via another one. That one gets called by another upper tier method, and so you're getting coverage on it, but you're not truly unit testing it, you know, because it's private. Well, if you add that test visible annotation to it, then you can kind of test it like it was public. So that's nice as well when you're in there in unit testing. So just some key takeaways today. Code with limits in mind. Keep the following out of for loops. You do not want DML, SOQL, or even SOQL, the search language. You know, in your for loops, if you do, you will most likely hit a limit, depending on where it is, once you get a batch of over 200 records coming in at a time. We talked about using static variables to prevent recursions. That example where you may have a trigger, admin adds a workflow 2 weeks later, and it comes back over the same trigger again. Avoid single action by bulkifying your code. Use of asynchronous to increase your limits. And the key is to assert that expected behavior. Don't use unit tests as a con just to meet that 75% coverage requirement. Try to actually assert them and create yourself a nice test framework that'll catch issues before they get out there in the real world. And so I have a list of references. All of these links will be included. I'll post the slides on the session feed today. These links just go into even more detail. Salesforce documentation is second to none in my opinion. And so you can dive into any of the topics that we've talked about. I even tried to use some of the code snippets from their documentation just so it would resonate if you go back. I also have shared the source for those trigger handlers via Google Drive, and I'll post those links to the session feed as well if that trigger model is something that you guys would like to implement. So all that will be out there. And then just your standard survey slide that we have, and thank you very much. And if you guys have any questions, I'd be more than happy to try to answer them.
May I ask a question?
Sure.
What's your favorite development environment for this?
I came from .NET, so I was a Visual Studio guy. I've been in Eclipse and Developer Console. It just kind of depends on what you're doing. If I'm doing something pretty simple, I normally just go for the Developer Console because it's all right there. But then if you're doing some more complex stuff, or if you're actually editing metadata, then I liked Eclipse. And Eclipse was nice too because if you ran into situations where you're renaming fields, which could be painful at times, you can do searches for that metadata in Eclipse, and it will search your entire kind of org. I haven't tried the new Cloud9 one that just came out too, that was announced this week, but that'd be something to look for too. They made a web-based IDE, and that's something to check out.